Good day everyone, here's our math challenge for today. So given these three congruent circles inside this quadrilateral having the base equals 10 centimeters. Now our goal is to determine the area of the region shaded in blue. Also, credits to Master Daniel Mentrard for sharing this wonderful question. You can follow him on Twitter at dment37. Now, if you want to try this problem, just pause this video right now. And if you're ready, here's the solution. And I hope you pause this video. Now let's see if you got the correct answer. To answer this question, we will use some concept. Now, if we have two externally tangent circles, the center of these two circles and the point of tangency is said to be collinear. This is not hard to prove. To prove that, we need to create a tangent line, and we know that the radius is perpendicular to the tangent line. It directly follows that the point of tangency and the two centers of these circles are collinear. Now, we will use this concept to answer this question. First thing to do is to consider the centers of these three congruent circles. Next, let's draw a horizontal line like this, directly to the point of tangency and the centers of the circle. And we know they are collinear. And also, take note that this horizontal line is perpendicular to the side of this quadrilateral. Now, let's label some parts. Let R be the radius of this circle. And since all circles are congruent, it follows that all of this must be equal to R. Now, notice that if we add all 4 R's, it is equal to 10. Therefore, we can say that 4R equals 10. Solving for R, divide both sides by 4, we get 10 over 4. Simplify, and we get that the value of R must be equal to 5 over 2. Now, keep in mind that the radius must be equal to 5 over 2. Next, after solving the radius of these congruent circles, we can now find the vertical height of this quadrilateral. To do that, let's connect the centers of this circle like this. Now, we create an equilateral triangle. Next, draw the radius of this top circle and draw the radius of this bottom right circle. And we know that all radius are congruent. Therefore, they are both 5 over 2. And to find the vertical distance of this quadrilateral, we need to have the height of this equilateral triangle. And also, take note that all radius of this circle is congruent. Therefore, all of this radius must be equal to 5 over 2. Now, let's focus on this equilateral triangle. Our goal here is to find the height of this equilateral triangle. Now, on the side, we have 5 over 2 and 5 over 2. If we combine them, we get a side of 5. Also, take note that this triangle is an equilateral triangle. Therefore, the measure of this angle must be 60 degrees. And the other angle is cut in half. Therefore, this is 30 degrees. Therefore, we can use the property of the 30, 60, 90 right triangle. Now, we can solve easily the other leg of this right triangle because the length of the side opposite of the 60 degrees must be equal to the measure of the side opposite of the 30 degrees multiplied by square root of 3. Therefore, the height of this equilateral triangle must be equal to 5 square root of 3 all over 2. Now, going back to our figure, we can now find the vertical distance of this quadrilateral. So, we have 5 over 2 plus 5 square root of 3 over 2 plus 5 over 2. Therefore, the vertical distance of this quadrilateral must be equal to 5 over 2 plus 5 square root of 3 over 2 plus 5 over 2. Now, factor out 5 over 2 will give us 5 over 2 multiplied by 1 plus square root of 3 plus 1. Now, 1 plus 1 will give us 2. Now, we can say that the vertical distance of this quadrilateral must be equal to 5 over 2 multiplied by 2 plus square root of 3. Now at this point, we are now ready to find the area shaded in blue. So the area of the blue region must be equal to the area of this rectangle or this quadrilateral minus 3 times the area of the circle. Now, let's find the area of the rectangle. So we have length times width. Substitute all the given values. We know the length and we know the width of this rectangle. We have 10 multiplied by 5 over 2 multiplied by 2 plus square root of 3. Now multiply and we get 25 multiplied by 2 plus square root of 3. Therefore, the area of the rectangle must be equal to 25 multiplied by 2 plus square root of 3 square centimeters. Now, let's find the area of the circle. It is given that the area of the circle must be equal to pi multiplied by r squared, or the length of the radius quantity squared. And we know the radius of the circle. We have pi over 2. Now, substitute the value of r. We have the area of the circle must be equal to pi multiplied by 5 over 2 quantity squared. Now, 5 over 2 quantity squared will give us 25 over 4. It follows that the area of one of the circle must be equal to 25 pi over 4 square centimeters. Therefore, the area shaded in blue must be equal to 25 times 2 plus square root of 3 minus 3 times 25 pi over 4 square centimeters. And as always, we're done.